Hey guys, so this is me going through the worksheet that you're going to be assigned to work on remotely or without me around. And so I'm just going to go through a few examples, make sure you understand the rules. The first part of the assignment asks you to solve by completing the square. On any one of these, let's take number 6. If I'm going to complete the square, okay, what we're going to have to do first is move the constant term to the other side. So I'm going to minus 63 from both sides. That'll become p squared minus 18p, and that will equal negative 63. The next thing I need to do is find the perfect c value. The way we find the c value is by taking the normal term, this not squared term, but that 18, we call it the b value. We're going to divide it by 2, and then we square it. Well, 18 divided by 2 is 9, and 9 squared is 81. I now need to add that number to both sides of the equal sign. So I'm going to add 81 to both sides. On the left-hand side, this should now be a very simple factoring problem. P minus 9 and p minus 9. I know it's minus 9 because the square root of 81 is 9, so it would be 9 and 9. The signs match, and to get a negative 18, I need negative 9 and negative 9. This equals negative 63 plus 81. I can grab my calculator. Plus 81. It's going to equal 18. Okay? And now I need to write this p minus 9 as p minus 9 squared equals 18. So completing the square was all about getting to that stage, and now to finish it, we need to get p alone by taking the square root of both sides. When you put a square root in, don't forget to put your plus or minus. So now p minus 9 equals plus or minus the square root of 18. Now I need to do something with that. I'll do that here in a minute. Let's go ahead and add 9 to both sides. So I know p equals 9 plus or minus the square root of 18. Now if 18 has a square root, if it's the square root if it was 36 or 25, I can just replace the whole square root with that number. But where this problem, that 18 doesn't have its own square root, I look to see, does it split into two roots? One of them needs to come from the list of perfect squares, 4, 9, 16, 25, and so on. The number that goes into 18 that belongs on this list is 9, and it goes in twice. Well, the square root of 9 is 3, so my answer should really be 9 plus or minus 3. That comes from the square root of 9, but there's a leftover root of 2, and that is how we use complete the square to solve these problems. All right, let's look at what happens when we do it by factoring. Now, factoring, there's a couple of different things. There's the really easy factoring problems like number 10 and number 11. I do want to make sure you guys don't forget that when you only have the p terms, when there's no third term, the option is to do what's called a GCF. Okay, GCF factor. And the GCF factors, what do they have in common? They both have a p. Well, times by p plus 5. If you think about the distribution approach of distributing that p, the answers should come out as p equals negative 5. And when there's a p out here that's not added or subtracted anything, it always defaults back to 0. So in this problem, we got 0 and negative 5. A couple of easy problems, pretty easy answers to find. Remember, when you get to questions like 13, 14, 15, 16, these ones down here, it takes a little bit more work. We have to guess and check. So I'm looking at 16. 7k squared will split as 7k and k. Now 30 could be 1 and 30. Could be 2 and 15. Could be 3 and 10. Could be 4, not 4, but 5 and 6. I could guess lots of different options. I kind of know where I'm headed because I can see the 41. Oops, I put that in the, no, I did that right. And I'm trying to get a bigger number, so that's 7. I really want to multiply by something that's sizable. 6 times k is 6k, and 7k times 5 is 35k. Remember that because the 30 is positive, we're supposed to add these numbers to get 41. which if I add 35 and 6, I do get 41k. Now in order for this to work, I have to make sure my signs match, and I want this 41 to be a negative 41, which would mean I need both of those to be negative, which means I have that and that. It's equal to 0. I'm going to erase this real quick. You might have to pause the video. I'm going to erase this work down here. Now, what I need to do is figure out what makes this thing equal to 0. Since k minus 5 equals 0, I can assume that k must equal 5. Over here, remember the steps. There's 2 of them. We switch the sign of the thing with x. So instead of being a negative 6, I'm going to say positive 6 over whatever's in front of the k, or the x, which would be 7. So I got 6 over 7 and 5. Those are the first 2 options. Third option is to solve by taking square roots. Well, if you look at these, the x only shows up once in the problem. So all I need to do is get it alone. I'm going to minus 8 here. 7x squared equals, well, 344 minus 8 is 336. And I'll divide both sides by 7. X squared equals, well, 336 divided by 7 is 48. And to finish it, I need to take a square root of both sides. So x will equal plus or minus the square root of 48. But if 48 divides by one of my perfect numbers, I need to reduce this root. Turns out 16 goes in 3 times. Remember those lists of perfect numbers, right? 4, 9, 16, 25. Well, the square root of 16 is 4, so my answer would be plus or minus 4 with a leftover root 3. Okay? And then the last type of problem is to solve with the quadratic formula. If I look at 3 here, a is 10, b is 3, and c is 2. Quadratic formula is negative b plus or minus the square root b squared minus 4ac is 2, all divided by 2 times a, which is 10. So this comes out to be negative 3 plus or minus the square root of, and I'm going to put this in the calculator, 3 squared minus 4 times 10 times 2 is negative 71 all over 20. Now 71 does not divide by any of my numbers. It's a prime. You could check, but it's not going to divide by any of those numbers. So this could be it, except that I see that negative right there. That tells me my answer is supposed to be imaginary. So it's negative 3 plus or minus I root positive 71 all over 20. All right, so those are some examples of what I expect you to do. There's lots of different approaches. I want you to use each of the approaches when asked to, and we'll go over questions when I get back, when we're back together. All right, we'll see you guys in class. Thanks.